All right, so we are finally ready to officially start with section 3. So now you're going to start seeing axioms and theorems, and now we're no longer just doing mathematical logic, we're actually going to be doing mathematics. And for us, that means set theory. So I just would like to remind you what is meant by axioms and theorems. So axioms are kind of these propositions that we start with. So this white dot here represents a proposition. And you can use logic, so this wiggly arrow represents logic, which is what we have been studying, to make deductions from axioms. And whatever you can use with these arrows of whatever you can deduce using these arrows of logic, these are theorems. So when you start out, all you have is axioms, and you can use logic to deduce some theorems. And as you build things up, you have lots of theorems, and you can use theorems to deduce other theorems. So we are now finished studying with the first portion of the course where we study how these arrows of deduction should work. And now we're going to start introducing axioms and proving theorems. So these, each of these is kind of representing a proof, a line of argument that takes you from things that you already agree are true to new things that maybe you did not previously know are true. So here is our first axiom, axiom 1. And you'll notice in the notes that all of our axioms and theorems and definitions are numbered. So you can and you should in your proofs refer to them by their number or by their name. So this one is called reflexiveness for equality. And it says x equals x. But actually, since the x is this free variable in a standalone result here, there's an implicit universal. It's really just saying things are equal to themselves. So that is an axiom, and it's part of how equality works. Here's our second axiom, and this one is titled equality used. And it's telling you when you have an equality how you can use it. So it's an if-then, it's an implication, and saying if x equals y, then you may deduce this. Now, you'll notice that there's a proposition placeholder showing up here, phi, this capital Greek letter. When you see a proposition placeholder like this, the idea of the axiom is that it's actually telling you can put any proposition here and this will work. So just like in derived rule 31, where we saw free variables can be replaced by any terms, when you see a capital Greek letter, you can think of that kind of like it's a free proposition, and it can be replaced by any proposition. Sometimes the way people phrase this is that this is actually not one axiom, but an axiom scheme, a factory that generates axioms for you, one axiom for each proposition you might try to put in place of phi here. So here's the idea. Here's an example of how to use axiom 2. Suppose you know that x equals y. Then axiom 2 lets you deduce, well, all kinds of things. It lets you deduce that anything that you can say about x is equivalent to the same thing, the same proposition, but with the y in place of x. So, for example, you can deduce that the statement x loves z is equivalent to the statement y loves z. So this is what axiom 2 is enabling. And hopefully that's pretty intuitive, that that's how equality should work, right? If x and y are equal, then we think of them as the same. We're like identifying them. So the fact that x loves z should become equivalent, logically equivalent, to the fact that y loves z. If x and y refer to the same thing, if that's how we're thinking about equality, then x's loving z should be linked in truth to y's loving z. They should be true or false together. So mechanically, how am I actually getting this out of axiom 2? Well, I'm applying axiom 2 to a particular choice of x, namely x, a particular choice of y, namely y, a particular choice of a, namely a, as you're about to see, and a particular choice of phi. So let me be clear about what choice of phi I have have made here. So what I've done to get this conclusion here is I have applied axiom 2 to the case where phi is A loves Z. Is this proposition A loves Z? And so hopefully you can convince yourself that this really is what I did when I wrote this down, this equivalence down. The left side of the equivalence is phi with A replaced by X. Indeed, when you replace A by X, you get X loves Z. And then here you get the same thing, but with A replaced by Y. Here you have Y loves Z. So this is how you use equality. If axiom 2 says if two things are equal, then anything you can say about one thing is going to be true if and only if the same thing is true, but about the other thing.